Hello everyone, I am santhosh.dk, Assistant Professor, Department of Computer Science and Engineering, Canara Engineering College, Mangaluru. I am going to discuss data structures with C laboratory course with subject code 18CSL38. In this course, we will be conducting 12 experiments, and any study material regarding this course is available on my website. Along with that, you'll also get a study material on C language and varieties of other subjects which I handle. Also, you'll get the opportunity to use online compiler in my website. You can run the code on the go.
Hi all. In this video, we will discuss experiment number 11. The experiment number 11 is all about traversing a graph. Before traversing a graph, what we are going to do here is we are going to create a graph of n cities, and we'll traverse a graph to check whether the cities are reachable from the given source. For that, we are going to make use of standard graph traversal functions, algorithms, DFS or BFS, any one we can make use. So we'll be going with the BFS algorithm, which is breadth first search. Before getting into the traversal and the programming implementation, let's see what is graph is. The graph definition goes like this. A graph is a non-linear data structure consisting of finite set of vertices and set of edges which connect a pair of nodes. So this is the example graph over here, what you can see. See, 1, 2, 3, 4, 5. These are the vertices, which we can call it also as nodes, and the connection between them, we call it with the edge. So there is the edge between 1 to 5, 1 to 2, and 1 to 3. Like that, we are having a edges. Let's see the types of graphs. There are two types of graphs, undirected graph and directed graph, and this experiment is based on the directed graph, which we call it as a digraph. So digraph will be having a direction of the edge, and the undirected graph is not having the direction of the edge. What are the operations we can perform on the graph? So first we have to create the graph. So to create the graph, again we are having two techniques. We'll see in the next slide. And once after we are having a graph with us, we can traverse the graph to check for the connectivity or to check for the reachability of the node from the given source node. So for that, we are having two well-known algorithms, breadth first search and depth first search, and the question is on using any one of them. So we will be going with the breadth first search, where we have seen already the data structures called stacks and queues. So the breadth first search will make use of the queue when it is going to find a reachability of a node. Depth first search is going to make use of the stack. You can call it as BFS is the application of queue, DFS is the application of stack. Before getting into the creation of the graph, we'll see how we can represent the graph in the memory, computer memory. See, this is what is the graph we are going to write on the paper, but on the same way we cannot store in the computer. To do that, we are having two techniques. One is adjacency list. This is how the adjacency list looks like, where you can make use of lists and you can store the values. And the other one is adjacency matrix. This is how the adjacency matrix looks. The adjacency matrix is a n cross n matrix, which is a square matrix. First you have to tell how many cities you are having, how many nodes you are having. So based on that, it's going to be constructed. And this example or this experiment is using adjacency matrix. Let's see how to create a adjacency matrix for the given graph. This is the example graph I'm going to take, and I am creating a two-dimensional array. I told it's a square matrix, so I'm going to take a two-dimensional array. So there are 5 nodes in the graph. So that's why I'm going to have 5 rows and 5 columns and 5 rows. Let's see how to fill these cells. Let's first consider the first node. First node, so node number 1, the node number 1 I'm going to take over here. Let's see, is there any connection, is there any edge between 1 to 1 like this? Is there any loop on 1 to 1? No, there is no loop. If there is no loop or there is no edge, you have to mention with the 0. If there is a edge, you have to mention with the 1. Now there is no edge between 1 to 1, so that will be 0. We are having 1 to 2. Let's see, is there any edge from 1 to 2? This is 2. The columns are 2, the rows are from. Is there any edge from 1 to 2? Yes, we are having a edge from 1 to 2. Let's mark it as 1. Next, is there any edge from 1 to 3? Yes, we are having a edge from 1 to 3. We are going to mark it as 1. Is there any edge from 1 to 4? There is no edge from 1 to 4, but there is a edge from 4 to 1. It is a directed graph when you should give respect to the direction of the edge also. So we cannot consider it is a 1 to 4, it is 4 to 1. So we should mark now 0 for 1 to 4. Next, let's check, is there any edge from 1 to 5? Yes, there is a edge from 1 to 5. It should be a direct edge, it should not be a edge by crossing the other nodes. Yes, there is a edge, we are going to mark 5 with 1. Let's take up the second node now. Now second node is the from. Let's see, from second node to 1, node 1, do we have any edge? No, so we'll mark it with 0. Is there any edge between 2 to 2? No edge, so we'll mark with 0. Is there any edge from 2 to 3? No, we'll mark with 0. And is there any edge from 2 to 4? Yes, there is a edge from 2 to 4. We'll mark with 1. Is there any edge from 2 to 5? Yes, it is there. We'll mark with 1. Similarly, we'll go with the 3 now. Is there any edge from 3 to 1? No. 3 to 2? No. 3 to 3? No. 3 to 4? Yes, there is a edge. And 3 to 5? No. Similarly, 4 to 1? Yes, there is a edge. 4 to 2? No. Sorry, there is a edge. 4 to 3? No. 4 to 4? Yes, there is a edge. 4 to 5? Yes, there is a edge. And let's take up the last node where all the edges are pointing to 5. In degree of this, we call it as a in degree. The in degree of 5 is 3, and out degree, the edges which are going out from the 5 is 0. So all should be 0. We'll mark it with 0. So this is how we are going to write the adjacency matrix for a given graph. You will be given with this type of graph. You should be able to write this type of adjacency matrix for a given graph. And it is easy. If you are going to consider from and to, and if you are going to construct a square matrix of n cross n nodes, you can aram se complete it. Let's see how to do this with the help of coding. So this is a simple n cross n matrix. It's a two-dimensional matrix. So where we are using a two-dimensional array. So what we are going to do is, first we are going to ask n number of cities, how many cities are there, or how many nodes are there. Then after that we are asking to enter one by one elements in the format of, better to enter in the format of matrix. So where that will be read with the help of two for loops. The J loop is concentrating on the column, and I loop is concentrating on the rows. It's going to read n cross n elements for the given adjacency matrix. Next we'll see what is breadth first search, how it's going to work, how it's going to find the reachability of a given node in the given graph. So now BFS, what algorithm over here I'm explaining is a recursive algorithm. First, the initialization of this algorithm is, what we are going to do is, first we are going to read a source node. If you are going to find the reachability, you should start from particular node. For that, what we are going to do is, we are going to read the source node. Then initially I am assuming that I have not visited any of the nodes. I cannot visit any of the nodes. So by assuming that I am having a single dimensional array called visited, I am marking for all the nodes. In our example, we are having 5 cities, 5 nodes. I'll mark from 1 to 5 for all the cities 0. 0 means what? I did not visit. 1 means I have visited. And I am starting from the source node. The source node V is given where I am starting. So what I am doing is I am setting that particular source node is visited by specifying visited of V, whatever the number I have given here, is equal to 1, because when I am starting from the particular node, of course I have visited that node, that's why I am beginning from that. So I am considering it as a visited and I will be beginning. And now I am going to call the BFS breadth first search algorithm with the visited node whatever I have visited. If I take 1 is the source node I have visited, now what it will do? It will check for all the nodes in the list, the given adjacency list. Check for a direct edge between source V and the remaining nodes which are not visited. So you have to you are having a two condition over here. It should have a direct edge between source V and remaining nodes. It should be a direct edge, and which are not visited by any other route. Then only what you have to do is, if there is a direct edge, insert that node into the queue. I said BFS is an application of queue. So what I am doing, all the direct edge containing nodes and which are not visited, I will insert all those nodes into queue. And you know how to insert. Whenever you are inserting a node into the normal queue or element into a normal queue, the insertion will take place in the rear end, and rear should be incremented. Initially rear is -1 over here, so rear is pre-incremented and it's going to be inserting all the nodes in the loop. Next, once after this is done, check for a non-empty queue. So what all the elements have already inserted into the queue. So what I will do is I will go one by one node and I will mark them as visited. So if it should be non-empty queue, if it is an empty queue, this is going to be the end of the recursive function. Then what I do, if there is a non-empty queue, I will take up the node from the front. You know how to remove the element from the queue. The insertion will take place from the rear, and the deletion will take place from the front. So now what I am going to do is I am going to mark the front element in the queue is visited. That is why what I am doing over here is visited of q of f is equal to 1. I am marking it as q of f, which is the node, that value on the visited place. I am going to mark it as 1. And now what I will do, I will call recursively BFS with the queue front, whichever the node I have visited just now, recently. I will call it recursively, and I have already visited that. So what I have to do, I have to delete it from the front of the queue. So that will take place in one line, that is BFS of q of f plus plus. What I am doing is I am calling the function, then I am going to change the front pointer. I am pointing to the next element. When I am changing the pointing of the front to the next element, automatically it means I have deleted the previous front element. Once after this is done recursively for all the nodes, so you will be having a visited list where it's going to have all the visited nodes from the given source, and that you have to print at the final output. We will see this with the help of example. This is a graph what we have taken, and for the same we are having a adjacency matrix. So let's see the initialization. The initialization should be, as I said, I'll be going with a source as 1. So I'll be starting with this, and I said I'm going to initialize visited as 0. I have 5 cities, 5 nodes over here. So I'll mark everything is 0. Initially I am thinking I have not visited none of the cities, but I started with source vertex 1. So it means I have visited that. Before that, let me create a queue. I have created a queue where rear is -1, front is pointing to 0, and always this is the condition which should match when you are creating a normal queue. Next, I have visited source vertex 1. So that's why I'm marking source vertex 1 as visited. Next, what is the condition? Next, I have to see from 1 here, I have to see the direct edges from 1 to remaining 4 nodes, including 1 also. And you can check is there any edge from 1 to 1? No. If there is a edge also, it will not be considered because already 1 is on the visited list. Next, is there any direct edge from 1 to 2? Yes. Did I visit that? No. Then you are free to insert this to queue. Now Q2 is inserted in the queue. Node number 2 is inserted in the queue. Next, check similarly, is there any direct edge from 1 to 3? Yes, direct edge is there. And whether it is visited? No. Then you are free to insert that to queue. And I have to remove this R. I forgot. I will remove that in the next coming animation. Next, now currently R is pointing here. Don't confuse with this R. Next, I'm going to visit, check whether is there any direct edge between 1 to 4? No. So it will not be considered. Next, there is a edge from 1 to 5? Yes. And whether it is visited? No, it is not visited. Then what I will do is, I will insert that to queue. Now this is the current R pointer, rear pointing. This is also I forgot to eliminate. Next, this is done with respect to node 1. Now what is the next case? You check for whether front is smaller than rear. Yes, front is smaller than or equal to rear. Front is 0 and rear is 2. This condition is true. Then what I have to do? I have to take up the front element from the queue and I should do the same procedure again. And so I have taken that. With that, I have called the BFS of 2 now. Now when I called BFS of 2, it is nothing but I have considered in the visited list. Now you can see I have considered in the visited list. And now what I have to do? I have to check for the direct edges between 2 to remaining nodes. Before that, let me draw edge between 1 to 2 because I have visited 2 through 1 with the help of 1. Next, same as I did for 1, I will go with the 2's row. Let me check, is there any direct edge between 2 to 1? No. 2 to 2? No. 2 to 3? No. 2 to 4? Yes, there is a edge. And whether 4 is visited? No. Then add that to queue. Insert it to queue. Next, same you check with 2 to 5. Yes, there is a edge from 2 to 5. Whether it is visited? No, it is not visited. Then you add this to queue. Now, which is the next node? Next node on the queue is 3. So now the row from 2 is over. Next job is to remove one element from the front of the queue and do the same task. Now what I will do? I am going to visit for 3. So that's why I am adding source as 3 now. Next, I am going to mark it as 1. Yes, because I am starting from 3 now. I am going to mark it as visited. I forgot to remove this. I'll remove it in the next animation. Let's see with the 3 in the row of adjacency matrix. Is there any edge from 3 to 1? You can check. No, there is no edge. 3 to 2, no edge. 3 to 3, no edge. 3 to 4, yes, there is a edge. And it is not visited. So what I have to do? Let me add that to queue. Next, what I have to do? Is there any edge from? I forgot to add it to queue. I should get 4 over here. I forgot to add it. Yes, I will add it now. Yeah, now 4 will be here and R will be pointing to this. Yes. Now let me continue. Yeah, let me continue. Is there any edge from 3 to 5? No, there is no edge. So what I will do is I will not continue here. Next, I will go with the next element. 3 is already visited. I forgot to remove this. Next element is 5. take up the 5 and mark it as visited. Yes, 5 is visited. This I entered little late. Yes, 5 is visited. Now what I will do, I will check the fifth row where is there any edge from fifth node to remaining nodes. There are no edge from fifth node to remaining nodes. Then I need not to mark this. Only thing is I have to mark here 5 is visited and let me draw. Here you can see I started with 1 and I have connected all the nodes which are directly connected to 1. That is what is called as breadth first search. If it is a depth first search, it will go in detail about the depth, but here it's going with the breadth. Now with 1 I have direct connection to 2, 3 and 5 which are visited. Let's see with the next node. Next node is 4. Now 4 is visited, yes, and mark it with the 1. Now it is eliminated from the queue. Now F is pointing to 5 and go to 4th row. Let's see whether there is a edge from 4 to 1. Yes, there is a edge, but check whether it is not visited. No, it is visited, so I cannot add it to queue. Let's see 4 to 2. Yes, it is having a edge, but it is already visited. You cannot add it. Next 4 to 3, no edge. 4 to 4, yes, there is a edge, but it is also visited. 4 to 5, there is a edge, but it is also visited. So this is the how it's going to visit all the nodes. Now again what I will do, I will call up the same with the help of 5 and I'll remove that from the queue. But already 5 is visited, nothing is going to affect on the visited list. Just it's going to eliminate that 5 from the queue. Next again the left out is 4 on the queue. What I will do is again I will check for whether it is visited. All the nodes which we have seen already, if I am going to eliminate, these are already visited. So if these are already visited, this is again not going to work and just I have eliminated that from the queue. And what was the condition? Friend should be lesser than or equal to R, but here the condition is failed and this is going to come out of the recursive function. And now we can check, I have all the visited nodes over here from the source 1. From the source 1 I have started, I have all the visited nodes over here. Now my job is to print all these nodes using the simple single dimensional array visited with the one single for loop and print. Let's for this. So first we have to enter the source vertex as we have seen, and the source vertex should be lesser than, should not be lesser than 1, should not be greater than n. Otherwise it will be a vertex which is not exist. That's why first on in the beginning only we are going to check whether it's a valid vertex or not. If it is a valid vertex, then only we will try to find the reachability. Otherwise we will not try to find the reachability. Next, if the given vertex 1 is valid, yes, then what I will do, I said initially I am going to mark everything as not visited. So that is done with the help of this one for loop. Then what I am going to do, I have already started with the source vertex v. I should begin considering that as I have visited. So that is why visited of v I set to 1. Then I am going to call the recursive function bfs of v. With that vertex I am going to begin. So this is the recursive function where, as I said, I am going to check for a condition for all the nodes. If AV of I, this is going to concentrate on the adjacency matrix and this is going to concentrate on the not visited list. If these two conditions are going to match, if there is a edge, direct edge between the source vertex and the remaining nodes, and if they have not, that respective vertex is not visited, then only I am going to add it to queue. Otherwise, if that is over, what I will do is I will keep on removing the element from the queue until it is going to get empty, and I am going to call this function recursively, and I am going to remove the element once I am going to call the function from the front of the queue. And once after this task is done, what I will do is I am going to display a message, the reachable nodes from the given queue, given source vertex with that, what I'm going to do is I'm going to just have a for loop where I'm going to check whether there is a visited entry and it is not the same source. Then what I will do is I'm going to print all the nodes which are visited from the given source. I cannot tell the source is visited from the source. That's why I'm going to have one more condition here is I is not equal to V. Both should not be same. I should be, then only I'm going to print all the nodes which are visited from the given source. Let's see how the main function looks. As like the previous programs, the main function is an infinite loop which is going to give you an option to create a diagram of n cities where it's going to read some n cross n matrix, and it's going to ask you print all the nodes reachable from the given starting node in the diagram using the BFS method. They have given clear option for us to go with either BFS or DFS. We are choosing BFS over here. And once you enter a choice, if it is a create graph, it's going to call the create graph function. If it is not a create graph, if it is a reachability checking, then it will go to the second choice. And these are all the things which I have explained just before. And finally, it will come out of the program. This is the references I made to explain this experiment. We'll see the demo. Let's see the output of graph traversal. Before that, I'm just giving a brief overview of the code where I'm having a adjacency matrix which is 20 cross 20. So up to 20 cross 20 nodes we can give. So if you want more than that, you have to change over here. I've taken a queue and I have taken a visited. So I have taken visited of 10. Like if you want, you can increase that also. I'll make it to 20. Yeah, all are 20 now. And I have taken n is for number of cities, I and j for the loops, and front and rear for the queue. And create graph is a simple function where it's going to read n cross n matrix with two loops. And BFS function is a recursive function which is having a for loop which is going to add all the nodes which are visited from the which are having a direct edge from the given source vertex which are not visited in this loop, and the next condition is going to repeat until all the elements in the queue are going to be removed, where it's going to mark them to the respective nodes as visited, and it's going to call a recursive function BFS of queue front. Meanwhile, it's going to remove the element from the front. Next, we are having a main function where it's going to give you a choice for first one is to create the matrix, that is creating a graph. The second one is to check for a reachability from the given source. The first choice goes with the creating a graph. Second choice will go with the reachability, where it's mandatory how to give a source vertex from where you want to start. And as I said, if it should be between 1 to n. If it is lesser than or if it is more than n, it's going to give you an invalid vertex message. Then after initialization of the algorithm shows, you have to mark all the visited 0 initially, and you have to mark the source vertex is visited. Then you call the BFS recursive function. Once after BFS recursive function is going to mark all the visited nodes in the visited list, we are going to display all the visited nodes by making use of the for loop and the if condition. Let's see the output. Yeah, here it is asking for a choice. First, I'll go with the creation of the graph. I have gone for choice number 1, and it's asking for number of cities. I'll go with a graph which I have explained in the demonstration. I'm taking 5 cities, 1 to 5, and it's asking for the adjacency matrix. We have to give a adjacency matrix over here. So for the same graph, I'm giving the adjacency matrix, which should be n cross n, that is 5 cross 5, 25 values I have to give. So each row should contain 5 values. So this is how you are going to write. I have already explained in the PPT explanation. Now the same values I am entering over here. It shows for the vertex 1, it is not having a edge from 1 to 1, it is having a edge 1 to 2, 1 to 3 edge is there, 1 to 4 no edge, 1 to 5 edge is there. Similarly, if you take up a vertex 2, node 2, no edge from 2 to 1, 2 to 2, 2 to 3, no edges. 2 to 4 there is a edge, 2 to 5 there is a edge. We will mark it with a 1. And if you go with similarly for third vertex, third edge, sorry, third node, 3 to 1 no edge, 3 to 2 no edge, 3 to 3 no edge, 3 to 4 there is a edge, 3 to 5 no edge. Similarly for 4, 4 to 1 there is a edge, 4 to 2 there is a edge, 4 to 3 there is no edge, 4 to 4 there is a edge, 4 to 5 there is a edge. When it comes to vertex 5, there is no edge from vertex 5, so I'll have marked everything as 0. Let's see the second option now. Print all the nodes reachable from a given starting node using the BFS method. Now I'm going to choose the second option, and as I have explained in the PPT explanation, now I'm giving the source vertex is 1. See, as we have already seen, from the source vertex 1, we can visit all the nodes 2, 3, 4, 5. All the nodes are visited. But let's see whether we can able to visit all the nodes by using 5, because 5 is a dead end. We don't have any edges moving from 5 to other nodes, so it should not visit any of the nodes. Let's again check for the choice number 2. Now I am giving source vertex is 5. Let's see. No, see, you can check out the reachable nodes from 5 is none. There are no nodes which you can visit from the 5, because it is a dead end from we have seen in the graph. I'll show you the graph also. Yeah, you can see over here the graph. It is the dead end where it's not going to allow you to visit any other nodes from this. Yes, hope it is clear for you. You draw your own graph and try to bring up a adjacency matrix, then give the values to the program and check for reachability. Thank you.